If we want to talk about nonlinear equations, we first need to define what nonlinear equations are. And the explanation, the definition is very simple. If there is at least one variable with a power different than 1, then we have a nonlinear equation. Like in this case, we have x to the power of 7 and x to the power of 4 over 3. Those numbers are not equal to 1. That means this is a nonlinear equation. Let's view a couple of examples, like this one. Yes, we do have the negative 2x, which is to the power of 1, but this 4x is squared to the power of 2. So the fact that it is to the power of 2, it means this is a nonlinear equation. Let's clean the board so we can take a look at another example. 25 square root of x equals 100. Let's take a closer look at the square root of x. As we already know from previous units, we can turn all radicals into fraction exponents, and actually the square root of x turns into x to the 1/2. And now this x is to a power different than 1. Well, it was always to a power different than 1, but now we can clearly see it. We can see it better that the power of that x is different than 1, which means this is also a non-linear equation. And since we have identified now what are nonlinear equations, let's learn how to solve them. And we're going to start with one-step nonlinear equations. And the definition is the same as if they were linear equations. If we only need one step to solve them, then it's a one-step linear equation. Let's review the concept of the equation before we proceed to solve it. The equation is going to have an equal sign. This equal sign is going to break the equation in two sides, the left side and the right side. Those two sides must be equal to each other at all points, because that's what the equal sign represents. They must be equal at some point. So everything we do on one side, we have to do it on the other. That rule stays. Now, if we want to solve for x, the x is on the left side and is next to 2, an exponent of 2. So in order to isolate the x, we need to take that exponent of 2 and move it to the right side of the equation. And how do we move that exponent of 2? The same way we have been moving numbers and things around our equations, using the inverse operation. But now the question is, what's the inverse operation of an exponent? It's a radical, as simple as it is. The inverse operation, or the opposite of an exponent, is a radical. So if we have an exponent of 2, we make a radical of index 2. That way, the radical and the exponent cancels. But guess what? The golden rule of algebra remains. If we do it on one side, we must do it on the other side. So if we do the square root on the left side, we must also do the square root on the right side. And now we do the operation, the square root of 36. We can do this by hand, we can do this mathematically, we can look at the tables, we can use the calculator, and we can get that is equal to 6. So x is equal to 6. But the problem is not over yet, because we have to take a look at the index of the radical. When the index of the radical is an even number, like in this case, 2 is an even number, we have a positive and a negative answer. So because the index of this radical is an even number, which is 2, our answer is 6, positive 6, but it's also negative 6. And these two solutions are part of the answer. Now, depending on the information that the problem gives us, we can select whether the positive solution is the right one, whether the negative solution is the right one. Sometimes both of the solutions are the correct one. Sometimes none of the solutions is true, but that depends on the previous information the problem gives us. And this is mostly on word problems, but we will get to that in further lessons and further courses, mostly in Algebra II. Let's keep practicing for the moment how to solve one-step nonlinear equations. Let's take a look at this problem. Now the x has an exponent of 4. Yes, we're still going to do the inverse operation of an exponent of 4. And the inverse operation of an exponent is a radical. The important thing is that the index of the radical matches the number in the exponent. So if we have an exponent of 4, then the index of the radical is 4. So this is fourth root of x to the power 4. Because the index and the exponent match, they cancel each other. But one more time, if we do it on the left side, we must also take the fourth root on the right side. Now we can do the calculation. The fourth root of 256 is equal to 4. But one more time, let's take a closer look at our index. Our index is 4, and 4 is an even number, meaning we'll have to consider both the positive and the negative solution. So x equals -4 is another solution. And the two solutions for this problem, or the two possible solutions for this problem, are x equals 4 and x equals -4. Let's review one last problem. X to the power 5 equals -243. The exponent of 5, we need to move it to the other side using inverse operations so we can isolate the x. The inverse, or the opposite of an exponent, is always a radical, but we have to make sure the index of the radical matches the exponent. Because both of them are 5, we can cancel them. One more time, whatever we do on one side, we must do it on the other. So we also have to take the fifth root of -243. Now we do this probably easier if we do it in a calculator. And we get x equals 3. But always when dealing with radicals, we must take a closer look at the exponent. Because now the exponent is odd. When the exponent is odd, we only have to focus about one answer. But the answer must have the same sign as the number inside of the radical. So because the number inside of the radical is -243, then our answer must be -3. So the signs match, and x equals -3 is our final answer.